Hello, I'm Jace Holmes, and this is my Physics 2212 Lab 2. Just to start us off, this lab's pretty similar to the last lab. We need to observe the transfer of electrons through tape, and remodel and re-estimate the number of electrons transferred, no longer assuming point charges. Now, to get into the equations, we're going to be dealing with Newton's second law, where the force of gravity is equal to mass times acceleration, and Coulomb's law, getting the force due to an electric field, and as well as Newton's third law, where every action has an equal and opposite reaction. So, to recap from Lab 1, our system is the tape, and the surroundings is everything else. We got a piece of tape and gave it a charge, and after hanging the tape by objects like a balloon, my laundry, and my hand, and it was determined that the tape was positively charged. From some assumptions and calculations, we got the tape mass to be 0.21 grams, we have its tape dimensions, and all of the calculations we did in the last lab to determine the number of electrons lost, the charge on the tape, and the electron to atom ratio. Now, in the recap for the Lab 1 GlowScript code, we just have all of the code, and the plot on the right shows that we have an equal and an opposite electron and gravitational force, both up and down. Alright, now to the Lab 2 GlowScript code. Most of this was given to us and we only changed a couple things. I input just some physical constants at the top, and my tape dimensions and physical properties right below that. Below the physical constants is the code to determine the electric field, and almost everything else on the right side is just for scaling and actually drawing up the plot. Here we have the final part of my GlowScript code, and as well as the plot that we got from running the code. Now, what if we had modeled each of the tapes as a single point charge like in the previous lab? Well, in the plot shown on the right, we can see that the gravitational force pointing down is much, much greater than the electric force pointing up. This means that with the data I got, this experiment would be totally fraudulent. There would not be nearly enough electric force to push the tape to the height that I measured it at. And in Lab 1, I got that my charge was 1.24 e to the negative 8 coulombs, and I got the charge of the line to be 2.0601 e minus 8 coulombs. This is nearly a 211% increase, just showing how the assumption of a point charge is very bad, and nowhere near its true value. But why do these estimates differ? Which value is more likely to be closer to the real value, and why? Well, like I had mentioned previously, the models predict different charges because they have different assumptions being made. The point charge model is not nearly as accurate because it doesn't account for the charge between the two ends. The point charge model assumed that there were two charges, one fixed at both ends of the tape. However, the line model does not assume this. The line model assumes that there's a constant flow of electrons at a constant rate anywhere between both ends of the tape.